Okay, so here we are. We are getting ready to start kind of a series of some mini units. Some of these are algebra standards, some of them are actually 8th grade standards, that we're going to be able to get through some material, quite a bit of different stuff in the course of the next few weeks. So today starts the topic of absolute value equations and graphs. We split this up into a couple of days. Today we will be solving equations that contain absolute value in them. So a couple vocabulary terms to write down. First is absolute value. The absolute value is the distance that a number is from 0 on a number line, and it's denoted with those two vertical bars. So we would read that expression there as the absolute value of x. And then we also have an absolute value equation, which is simply an equation that contains absolute value expressions. And I don't really like my use of the dash here, so I'm going to take that out. I don't know why that's there. There we go. Okay, so let's talk about an absolute value equation. When you have an equation that has an absolute value in it, it's basically asking what values will have an absolute value of a. And so when you see that equation there, the absolute value of x equals a, it's asking you what values of x have an absolute value of a. The solutions then would be a and the opposite of a, because you know that the absolute value of a positive or negative number then gives you that positive answer. When you look at it in terms of numbers, the absolute value of x, if the absolute value of x equals 5, then x could be 5 or negative 5. There's that a and the opposite of a, 5 and the opposite of 5, which is negative 5. On a graph, because absolute value is a distance away from 0, we could be going in the positive or in the negative direction. So you could see that a units away from 0 to the left would put us at negative a, and a units away from 0 to the right would put us at positive a. Using algebra, we say the absolute value of x is equal to a, then x could either be a or negative a. And we'll talk about some special cases, but a does need to be greater than or equal to 0. When we solve absolute value equations, we have to consider two cases. And so that's really the difference between solving equations with absolute value or just solving regular equations, because there are two situations or cases that we have to consider. So let's just do some examples and you'll see what I mean in just a minute. So here we're asked to solve the equation and we're going to check our answer. I don't know that we see it so much today, but in the future we will see absolute value equations where when we check our answer we find that it's not actually a solution. Most of my checks will come today just kind of in my head. You'll hear me thinking out loud. A couple of them I will write down. So solve the equation. The first thing that you need to do is make sure that the absolute value is isolated. There can't be anything on the other side that's outside of the absolute value. You can't have a number in front being multiplied by it. You can't have anything behind it being added to it. Inside the absolute value, it doesn't really matter what's in there, but outside the absolute value, it has to be isolated. And here it is. We have the absolute value of x, it's all by itself, and we're told that it's equal to 4. Once you have that, you are then going to write two equations. Okay, I'm going to drop, I'm not going to drop the absolute value just yet. Okay, no, sorry, I am. But I'm going to write these two different equations, setting the first one equal to 4 like I see, so I have x equals 4, but then also that other case where x could be negative 4. Now from here we would solve each of these equations until we had x isolated, but you can see here that they are actually both isolated, and so these are our two answers. X could be 4 or x could be negative 4. And we're going to check our answer. So I'm going to take the original problem and I'm going to plug both answers back in and make sure that they both work. If I take the absolute value of 4, do I get 4? Remember, when you check, you're kind of like asking this question. Yes, the absolute value of 4 is 4 and 4 equals 4, so that's true. Now let's try if x is negative 4. Is the absolute value of negative 4 equal to 4? Again, I'm kind of asking this question. The absolute value of negative 4 is 4, and we get 4 equals 4. Again, a true statement, so both of our answers work. These are the answers. This is a pretty simple case, almost so simple that it might seem a little bit confusing because there wasn't really a lot of equation solving technically here, in terms of having to move terms or numbers to the left or right side. But here we go. X is 4 and x is negative 4. So first, make sure that the absolute value is isolated. We have the absolute value of x plus 2 on the left-hand side. It is all by itself and it equals 4. So it is isolated. Now we're going to write two equations. This is the most important step. You have to do this, absolutely have to do this. So we have x plus 2 equals 4 and x plus 2 can equal negative 4. Think about that. If the inside of this is a positive 4, the absolute value of 4 equals 4. And if the inside of this equals negative 4, then the absolute value of negative 4 is also 4. So we're considering those two cases. Now we're going to solve both of these equations, subtracting 2 from both sides, and we get one answer of x equals 2. Subtracting 2 from both sides again, we're going to get an answer of x equals negative 6. Okay, so notice what we did. We had the absolute value isolated, then we wrote our two equations considering both the positive or the answer and then the opposite, solved both equations and got 2 and negative 6. So these are the two answers. X can be 2 and x can be negative 6. If I check these, if I plug this back into the original equation, the absolute value of 2 plus 2, does that equal 4? Well, the absolute value of 2 plus 2 would be the absolute value of 4, and the absolute value of 4 is 4, so it does check there. In the second situation, we have the absolute value of negative 6 plus 2, does that equal 4? Negative 6 plus 2 is negative 4, so we have the absolute value of negative 4. Does that equal 4? And yes, the absolute value of negative 4 is 4, and 4 equals 4. Number 3 is the first one where we see the absolute value is not isolated. You first have to isolate the absolute value. I have to get rid of the 6 that's being multiplied out in front by dividing both sides by 6. Now I have the absolute value of x minus 8 equal to 2. The absolute value is isolated, so now I'm going to write my two equations. I have x minus 8 equals 2, and I have x minus 8 equals negative 2. Solving both equations for x by adding 8 to both sides, I get x equals 10, and x equals 6. Now I'm going to start plugging this information back in on my own, just kind of thinking out loud mentally, does this answer work? If I plug a 10 back into the equation, so I'm going right here. 10 minus 8 is 2, the absolute value of 2 is 2, and 2 times 6 is 12, so 10 works. Plugging in a 6, 6 minus 8 is negative 2. The absolute value of negative 2 is 2, and 2 times 6 is 12. So both of the answers work. We get 10 and 6. So let's talk about special cases. So far, every problem we've looked at had an answer or an absolute value that was equal to a positive number, but not all absolute value equations actually have two solutions. So the first case, if the absolute value expression equals 0, there's only going to be one answer. That should make sense. I can't put 0 as positive or negative, and so I can't really write two equations. I'm only going to be able to write one, therefore just giving me one solution. Also, if you have an equation that states that an absolute value is negative, there are no solutions. And that's because the absolute value of a number cannot be negative. So there's where we get our no solution answer from. So let's look at one of each. Solve the equation, check your answer. So I have the absolute value of x plus 3 plus 4 equals 4. So my absolute value is not isolated. The first thing I need to do is subtract 4 from both sides. I have to isolate the absolute value. That gives me the absolute value of x plus 3 equals 0. Here you can see now I don't have two equations to write because 0 is not positive or negative, so I just write x plus 3 equals 0, and I go ahead and solve the equation by subtracting 3 from both sides, and I get x equals -3. I can go ahead and plug that back in. -3 plus 3 is 0. The absolute value of 0 is 0, and 0 plus 4 equals 4. So my answer does check. But there you can see here in this line, when you have the absolute value set equal to 0, you are only going to get one solution. Number 5, 2 minus the absolute value of 2x minus 5 equals 7. Again, we need to isolate the absolute value, so I'm going to start by subtracting 2 from both sides. You're just kind of treating the absolute value like a variable. So now I have the opposite, or negative, absolute value of 2x minus 5 equals 5. I do need to get rid of that negative. Remember, that's like having a -1 out in front, so I can multiply or divide both sides by -1 to get those to cancel. And now I have the absolute value of 2x minus 5 equals -5. So there we have an absolute value equal to a negative number. Absolute values never give you negative numbers. Remember, it's a distance from 0. Distances are always positive. So here we say no solution. We talk a little bit later when we start graphing these, what the graphs look like when there's no solution, because you can still graph this. So there's the special cases. When we come back to class, I will check the notes and we'll work on the absolute value A worksheet.